Welcome back to AI Verdict, the show where we cut through the noise and get to the facts. We've got a lot to cover today. We're talking a huge code leak that hints DeepSeek is about to drop something big, a new flash model from China that's bringing serious brain power to local machines, and, get this, a coding AI that's been trained through, well, basically punishment. All right, let's jump into the evidence. You know, it's a fantastic question, because the real bombshells, the biggest stories, they don't always come from a fancy press release. Nah, sometimes you find them buried deep in the code, just hiding there in plain sight. And that is exactly where we're starting today. Okay, so for our first verdict, we're not looking at some big official announcement. Not at all. This is all about the evidence, a digital paper trail that some super sharp developers found just by watching GitHub. And what they found suggests DeepSeek is getting ready to drop something huge. The clues they uncovered are, well, they're pretty fascinating. So check this out. The first big clue appeared on January 20th. Now, that date is important. It was the one-year anniversary of DeepSeek's first big model release. And on that day, they pushed a massive update. 114 files got changed. I mean, come on. That's no simple bug fix, right? That's laying the foundation for something brand new. And buried deep inside all of that was the smoking gun. And that clue? It's a simple little identifier, Model 1. But here's the thing, it shows up 28 times, so, it's not a typo. And what's really crucial here is that it's always kept separate from V32, which is the tag for the current DeepSeek model. And what does that tell us? It tells us Model 1 isn't just another small update. No way. This is a completely new architecture. Digging deeper, the devs found 3 huge architectural fingerprints. First, they totally redesigned the KV cache. Think of that as the model's short-term memory. They've souped it up for way more speed. Second, there's new sparsity handling, which is a really clever trick to make the model faster by teaching it to just skip over the parts it doesn't need. And finally, there's native FP8 decoding support, which is all about squeezing every last drop of performance out of the latest hardware. Seriously, these are not small tweaks. These are massive foundational changes. So, what's the verdict here? When you put all these pieces together, the theory is this is DeepSeek v4, and it looks like they're baking in their latest, craziest research. Things like modified hierarchical connections and a bio-inspired memory system they call Ngram. The code is practically screaming that a brand new flagship model is in the final stages of prep, and the rumor? We might see it drop around the Lunar New Year. Okay. Let's shift gears from these massive foundational models to something a little more hands-on. You know how it is with AI 3D generation, right? It's moving at lightning speed. But so many of the tools, they create stuff that looks amazing from the front, but then you rotate it and it just completely falls apart. Well, our next verdict is about a tool that finally seems to get it right. Yeah, this is Hind 3D2, and it seems like it's actually built for real work. The game changer here is that the textures are structured into the geometry itself, not just kind of slapped on top. It's smart enough to fill in the parts you can't see, like the underside of an object. And this is huge, it cuts down on that baked-in lighting. So you get these clean, beautiful materials that are perfect for game assets or 3D printing, places where the actual geometry has to be perfect. All right, our third verdict today is all about a model that's trying to solve a really big problem for a lot of people. How do you get top-tier GPT-4 level reasoning without needing a giant, expensive GPU cluster? Well, meet Z.AI's GLM 4.7 Flash. So why is this such a big deal? Well, think about it. Right now, the most powerful AIs are usually locked away behind some pricey API. You can't just download them and run them yourself. They're just too big. So local AI opens up this whole new world of cheaper, more private, and way more customizable tools. In GLM 4.7 Flash, it's aimed right at the heart of that need. And how does it pull this off? It's all thanks to this clever architecture called Mixture of Experts, or MOE for short. Now, the model has about 31 billion parameters in total, which sounds huge, but here's the magic trick. It never uses all of them at the same time. For any one task, it just activates the specific experts it needs for the job. It's incredibly efficient. It's basically power on demand. And don't think that efficiency means they've sacrificed power. Not at all. This thing supports a massive 128,000 token context window. And that's absolutely crucial for really complex thinking, for handling long, detailed conversations, and especially for those agentic workflows where the AI needs to remember a whole long chain of steps to get something done. Okay, for our next one, we're going to pivot a little bit. We're moving away from what AI can do and into how AI might actually understand us. This verdict comes from some really mind-bending research out of Japan, where they're trying to model human emotion not as a feeling, but as a kind of computational process. Yeah, stick with me here. So, their whole framework is built on something called the theory of constructed emotion. And the core idea is pretty wild. It says that emotions like sadness or joy aren't these pre programmed things hardwired into you. Instead, your brain is actually building them on the fly by mixing together two things: internal signals from your body, like your heart rate going up, and all the external data coming in from your senses, like what you're seeing right now. So these researchers took that theory and built an AI around it. They fed it a ton of data, both physiological signals and visual data, from people who are watching emotional videos. But, and this is the amazing part, they never told the AI what an emotion was. They didn't say this is happy or this is sad. The AI had to figure out the patterns all on its own. And the result? The emotional categories the AI came up with matched with the humans reported feeling 75% of the time. That's incredible. Look, the implications for this are just massive. We're talking about moving way beyond basic sentiment analysis, just guessing if a sentence is positive or negative. This is about understanding how emotional states are actually built. This could totally change mental health support, help us build robots that are genuinely more empathetic, and even aid people who find it hard to put their emotions into words. It is a profound, profound shift in how AI could one day interact with us. And for our final verdict today, we're looking at an AI that was built for one of the toughest challenges you can throw at a machine: competitive programming. But it's not what it does that's the story here. It's how it learned to do it. This is NewsCoder 14B, an AI that was trained through, frankly, a brutally efficient process. Just picture this training gauntlet. It is a simple, incredibly harsh loop. The model spits out some code, and that code is instantly run in a secure sandbox. If it passes every single hidden test, it gets a reward, +1. But if it fails, for any reason at all, it gets a penalty, -1. That's it. It isn't learning to sound like a good programmer, it's learning to survive. And when I say the rules are strict, I mean it. The model gets punished if the code fails those hidden tests, sure, but also if it takes more than 15 seconds to run, or if it eats up more than 4 gigs of memory. There is absolutely no partial credit. It's this unforgiving, high-pressure environment that forces the model to write code that isn't just correct, but is also lean and incredibly efficient. So the big question is, does all of this punishment actually work? Oh yeah, absolutely. On a really tough benchmark for competitive programming, the original base model scored just under 61%. Not bad, but after going through this training gauntlet, NewsCoder 14B jumped all the way to almost 68%. That 7-point jump is a huge deal in this space, and it proves that this high-stakes sink-or-swim training method really works. So let's just step back for a second. When you pull all of this together, you have one AI learning secrets from our code, another one learning about our emotional states from our own bodies, and a third one learning to be a great programmer through pure pass-fail punishment. It really leads you to one final, pretty provocative question. As these AIs learn from all these different parts of our world,